Dear colleagues, dear friends, can you hear me? Please, somebody reply that you are listening to me. Can you hear me? Oh, okay. Okay. I'm Dmitry Kochergin. I'm from technical support department of Russian company Racurs, and I'm really glad to... Okay, Vaska cannot see me. What? Can you see the screen? Can you see the screen, or you see just nothing? Vaska? Yes. Okay. Yes. We'll take care about video sometime later. Probably you will, next webinars you will see my face. Well, okay. So again, it's my great pleasure to announce that we are going back to our practice to make webinars, because as you probably know, there was a break about 1 year or something like that, but now we start a new sessions of webinars. And the first one is dedicated to radiometric processing of satellite imagery and PHOTOMOD system. It's actually a very important topic, because at least in Russia we got more and more projects related to satellite imagery processing, and sometimes data came from different sources with different radiometry, different colors, and so on, so on. So, excuse me, what happened? I was not able to switch to another picture. I don't know why. Okay. Of course, the idea of radiometry is to get image of the high quality with natural colors, and at the same time it should keep the details in some dark areas and some bright areas. We will take into account some samples from modern satellite sensors like WorldView, QuickBird, GUI, and Pleiades. I think that you know them, all of you. And so, as you probably know, all these images came to the customer like 16-bit image. But in fact, it's not 16-bit. In fact, it is usually 10-bit, 12-bit, and 11-bit, and so on, so on. So the source histogram usually look like this. Very big range of possible brightness values, but very small part of it are real, filled by real pixels in the image. So the idea is to get this histogram, to stretch it out, to make it bigger, to see all details and see all colors. I will switch between presentation and real PHOTOMOD system. So I'll go back here, and there is our samples from different sources. This is a radiometric correction window, and you can see that the source histogram again look like this. For example, it is blue channel, but the rest of channels look the same. So we need to stretch it out in some different ways. For example, now I'll do it by one of our methods available, standard deviation. I will talk about some of them later in details. So as soon as I click OK or apply, you'll see the image, because the histogram is stretched out, and now it looks like this: green channel, red channel, blue channel. Okay. So again, this is illustration for my previous section. Small histogram, wide histogram. So the idea is that I have to find somehow the start of the range of real pixel values and where is my mouse, and the end of the range. And then I take this small histogram and stretch it out between the origin and the end. Now about methods of this stretching, of this radiometric transformation. We divided it into two groups, auxiliary and basic. Auxiliary is separate channels and all channels, and basic is standard deviations and quick look. Quick look is a very new one and probably the best one. We'll talk about it later again. So, first about auxiliary techniques, auxiliary methods. Actually, it's easy to understand which is it, what is it. Separate channels, stretching histogram, and every channel separately, and all channels is stretching histogram, and all channels all together. Again, go back here, undo, and show you these two first things. Separate channels, apply, and all channels, apply. You see that picture is different. Actually, the color of this picture depends on the nature of territory, of nature. If you have green forest, you will see that the histogram of green channel will be bigger, and the total histogram will look more green. And so also it is the same thing. Illustration for this sample, all channels look like that, and separate channels look like this. And now about trimming off these parts of histogram. Again, if you go back here and turn on this tool, auto levels, you see this trim left and trim right parameters. And it means that when I set trim left like 10%, I will try to trim out this part of histogram. This is a black, actually kind of black pixels. And the right is white pixels. And the note is that you should be very careful, because sometimes you want to remove from radiometry noisy pixels, but you can accidentally remove useful pixels only. A pretty standard way how to divide the histogram into useful part and not useful part is using standard deviation. Standard deviation is clear, it comes from statistics science. Well, so you have some kind of mean value or expected value, and this is our sigmas. 1 sigma, 1 standard deviation, 2 sigmas, 2 standard deviations, and so on. So if I say, well, I want to remove all pixels outside 3 standard deviations, I will remove this part of histogram, and this part of histogram. Go back here, say standard deviations, well, 3, apply. See the picture like this. Now we can analyze the picture more carefully. You see that the colors is pretty good. But if you will zoom in on some special objects, this is something about oil things. I am not an expert in this area. But you see that we lost details of these objects on the ground. And in fact, in this case, it's very important objects. It's the objects that we really want to investigate. Okay, Now I will undo it and try another option. Auto levels, auto adjust. So PHOTOMOD is trying to define how many standard deviations we want to remove. Okay. Now you see that details are very nice, but the colors are not so real, not so natural. So that's the problem between these two methods. Well, the picture says also that auto levels with auto adjust give natural colors but good details, and standard deviations like 3 give us some kind of light damaged pixels, but at the same time colors are good. One more illustration: standard deviations with fixed value, standard deviation with auto value. Of course, if I enter over here the same number, you will get the same picture. Next, quick look. As you probably know, all modern satellite images are provided to the customers with some metadata, with RPC coefficients, etc., etc. At the same time, there is a file with quick look. Quick look is a small copy of the image, and in very most cases, quick look has a very nice quality. So we can use it like a sample, like an etalon. And if I again select auto levels with quick look option and click OK, now we see a kind of perfect picture. Details is fine and the colors is also fine. But of course it depends on the quality of quick look itself. And a bit about how the quick look goes to the PHOTOMOD project. This is files with the image provided by the owner of the sensor. And as soon as we create a project in PHOTOMOD, this file is recognized. It is quick look. It is quick look, overview, JPEG. The names of files are different for different sensors, but PHOTOMOD recognizes all of them, copy it to the project, and name it in such a way that PHOTOMOD understands what is it. Again, it is a sample that quick look itself, PHOTOMOD radiometric processing of the source image, they look very similar, as you can see. And again, standard deviations and auto standard deviations. Well, note is very important. Unfortunately, quick look option is not available in the current version, but but this feature is tested, it is done and finished, but we have some problems in some other parts of system, and hopefully it will be released in a week or so. Of course, I hoped to do it before the webinar, but unfortunately we did not do it yet. Okay. Now, well, one more illustration. Quick look, standard deviations, and so on. Now, what if the quick look is not so good? Then we need some manual tricks, some things about the image. I will close this window. Now I select another sample. It is QuickBird. And again go back here to radiometric processing. Undo. Quick look, apply. We see that the colors is basically fine, but some things again are light struck or something like that. Cancel. In this case, probably we need some manual work. I'm sorry. Well, can you hear me now? Yes, I am sorry. Probably something was wrong. Something was wrong, but, well, if last 6 minutes, well, the idea was that I showed last 6 minutes, as Vaska said, that there is no sound. I was trying to show how to play with the manual settings of the radiometric correction window. And the main idea is that the first option and the best option is a quick look. If it doesn't work for some reason, the first reason is that quick look is not so perfect itself, then you can play with some manual settings, manual methods, and so on. So I'm ready for the question. So I can repeat some steps if you want to. Of course, the webinar will be published on our website, and you can see it one more time. But again, the problem with the sound will be the same. Please repeat from quick look. From quick look, well, quick look itself is clear. You just select an option, quick look. But if you are not satisfied with quick look, you can well, okay, I'll try to repeat. Well, go back to this sample, to QuickBird and radiometric correction window. Okay, this is quick look. I mean, I can select quick look, okay, and for example, I am not satisfied with these parts of image because they are not detailed. In this case, I cancel my previous action and I make some manual things. First, again, auto levels, but with an option separate channels. Okay. I see the pictures with details, but with bad colors. Now I'll try to fix the curves, to fix the image by using the curves tool. Curves. And first I remove the black part of the pixels. Excuse me, again I forgot this option. Curves, not for all, for channels separately. Remove this part. Then I try to stretch out the histogram, to make it bigger, to get more information. You see that we have details, but of course the colors is not good because I did it only for one channel, and I do basically the same operation for the rest of channels. And as I said, but you did not hear it, the maximum values, the peaks of output histogram. This is peak of output green histogram, and this is peak of source green histogram. This is peak of output green histogram. And the idea is that the peaks of output histogram should be approximately at the same position, in the same position. So first I cut off this part, and then I stretch out the histogram in every channel and trying to get all maximum values in the same position. In this case, I see the details, I see basically good colors, and I see good details at the same time. There was also an illustration over here. If I go back, where is it? Yes, the coincidence of histogram peaks of different channels. It means that peak is over here, and over here. Of course, not perfect coincidence. And you see that the source peaks are in different position, but output peaks are basically in the same. So, questions? Where are you? Well, I can also repeat the very last sample, because it was also muted, the sample when I do everything manually. I make auto levels. I don't make any auto levels, I'm starting just with curves, and in this case I cut off several times the useless part of histogram. You see some stretching over here. First I have some image, and then I can play with it in such a way that I was showing before. Sorry, again, not for all. Outer curves, preview, channel by channel. So we see that I got big histogram, wide histogram, but I am trying to make details for this small object. Try to see the details of the roof. And I already see it, but of course I have to make the same thing for the rest of channels. Red, green, and blue. Curves. Green. And blue. Well, and as I said, this long part refers to the white pixels. So now I can tell that I have details and I have the colors at the same time. Okay. Still, excuse me, no. Example, stretch water. How can I see the max and min of values to stretch water? Well, you see the histogram, and you can define it visually. Unfortunately, there is no way to make everything automatically, otherwise it would be very easy. But again, as I said that I really want to make emphasizing on this quick look feature because it's a new one, and our experience for last couple of months give us the impression that the quick looks provided by the imagery providers are pretty nice, and so we can use it, and in this case everything will be basically automatically, including the water or something else. In some next webinars we'll talk about the color balancing for groups of images, of course, because now it was just about the individual source images in the project. But of course, the next problem will be how to combine them into mosaic, and there are also some tricks with the total color balancing. But this part is also very important to get as images of the quality of high quality, to take everything possible from every individual image to get it more to get it better on the step of the loading it to the project before mosaic. So any more questions? Okay, any more questions? friends, colleagues. If you have no questions, probably we can finish. As I said, of course, the webinar will be available on our site for downloading, and you can take a look on it one more time. Okay, it was very nice to see you around me. Okay. Okay, thank you very much, guys.